Hello there, this is the week 7 video. So last week we started looking at ways to collect data, and one of the ways that we looked at it is through surveys, and so you saw how to write good survey questions. And then you also learned 4 very important vocabulary words, and those were the population, the parameter, the sample, and the statistic. So one thing to keep in mind with these 4 vocabulary words is we really want to stay focused on what it is the researcher would like to learn about. Now, the researcher really wants to learn about the population. That's the group that they're interested in. And the thing that they would like to learn about that group is the parameter. Unfortunately, since the population is usually very large, we rely on looking at statistics, and we want to use a statistic to estimate the parameter. So in order to do that, we have to start looking at the behavior of these statistics, and that's really what today is going to be focused on. So what we're going to do is we're going to suppose that you have a whole population and that you're able to take many samples from that population, and from each of those samples you calculate a statistic. Now for right now, the statistic we're going to be working with is what is called the sample proportion. And so a sample proportion is where you look at a proportion that's taken from a sample. So as an example, let's suppose I was interested in the proportion of people that live in Kentucky and smoke. Well, if I'm looking at all the people in Kentucky, that would be looking at a population, and we would have what's called a population proportion. Whereas if I take a sample of 100 people and I find out of that sample of 100 people how many of them smoke, that's what we call a sample proportion. So a proportion is where you have one of 2 options, and you're looking at the percentage of times one of those options occur, and generally we write that percentage in decimal point form. This is discussed in those Module 2 notes that you printed off last week. Alright, so back to what our goal is. Our goal is to estimate a parameter using a statistic, but like I said, we have to look at the behavior of that statistic. So again, if I were to take lots and lots of samples, from each of those samples I calculated a statistic. I hope you would agree with me that the statistic is not likely to be the same from sample to sample. So in order to use the statistic, we have to know something about how it's changing from sample to sample. And so the first way we're going to look at how to do that this week is by looking at what we call a sampling distribution. So if you could take lots of samples, from each sample you calculated a statistic, and then you plotted those statistics in a histogram, you would start to see certain patterns. And these plots have special names. They're called a sampling distribution. And so you're going to see a worksheet today that's called the sampling distribution, or how to simulate sampling distributions. And that's what that is going to talk about. So make sure you watch the videos that are in the directions for that worksheet, and then go through and work through the worksheet, keeping in mind our goal here is to learn about the behavior of statistics and the patterns that they follow. From there, what you're going to find is if we plot these statistics, a whole bunch of them, the plots tend to have a bell shape. And so the next thing we're going to do is we're going to learn about that bell shape, and we're going to learn about the properties of the bell shape, because if we can do that, then we know something about the pattern of the statistics, and then we can start to hopefully use that pattern to really understand how to use the statistic to estimate the parameter, the thing we want to learn about. And so notice in this video I'm using that vocabulary a lot, so if you're still uncomfortable with it, go back and make sure that you get a good handle on those 4 vocabulary words from last week before you continue on. Otherwise, it's going to be really difficult to keep up. Now, I am going to offer some more bonus points this week. So what I'd like you to do right now is to pause this video, go through and complete that worksheet on simulating the sampling distribution, and then come back to this video for the bonus points. Okay, so hopefully you have completed the simulating sampling distribution worksheet, and what you found was if you take lots of samples and from each of those samples you calculate a statistic, so on that worksheet you calculated 30 statistics and you plot them, it is about bell-shaped. Now the bell shape probably wasn't perfect, and that's okay, because notice the theory claims that you had to take lots and lots of samples, and you only took 30, so it's probably not a perfect bell shape, but it should be somewhat close. And in fact, as you continued and taken even more samples, calculated a statistic for each of them, and so plotted even more statistics, you would get an even clearer bell shape. Now in the worksheet, you saw that the true value of the parameter is 50%. I want to show you in these bonus points that this what happened there will happen no matter what value of the parameter we work with. So what I'm basically going to have you do is to redo the simulating sampling distribution worksheet. And so previously on the web app, you had a spinner that was split in half, and that's how we knew the parameter was 50%. This time what we're going to do is I want you to change the spinner to split it into 4 sections. Now we're still going to be interested in the percentage of times that the spinner lands on blue, but notice now since we have 4 sections, we know that the true value of the parameter in this case is 25%. So I want you to go through and repeat the exercise, but now with the spinner split into 4 sections. And hopefully what you find is if you repeat that table where you take 30 samples, each of size 20, and you you plot those 30 statistics, making a sampling distribution, the sampling distribution is still going to be bell-shaped. But now instead of peaking above 50, it's now going to peak somewhere closer to 25, the true value of the parameter. And so if you kind of step back and think about this, this is really neat because when plotting that plot, when making that sampling distribution, you don't actually have to know what the value of the parameter is. That plot just naturally peaks above the parameter when you plot all of those statistics. And it doesn't matter what the value of the parameter is. This pattern is what we're going to eventually exploit to where we can start to use the statistics to learn about parameters. So the whole goal here is to start to learn about the pattern these statistics follow so that later on we can use these statistics to get an idea of where the parameter is located. And so next week we're going to introduce this idea called a confidence interval. In order to calculate a confidence interval, we need to have kind of seen some of this theory and have a good understanding of how the statistic behaves. So make sure, as you go through the rest of the work for this week, make sure you're really watching those videos carefully and reading all the notes that I have in the directions, because I'm going to have some stuff to kind of help guide you through this process of understanding about the pattern the statistics follow, and hopefully how we can eventually use that to estimate the thing we're really interested in, the parameter. Now, all you have to do for the bonus points is send me the new plot that you make where that plot has about bell-shaped and is going to be peaked above 25%. And if you email me that plot by Friday, I'll give you 4 bonus points on the next exam. So as always, if you have any questions, please let me know and I will talk to you later.